Everyone, welcome back to my channel. My name is Mr. Chai. Now today we're going to talk about integrations that involve natural log. All right. Now how natural can natural log be then? Right. Let's find out. We are back. We're going to talk about the integration that involve natural log today. Right. Now how natural is that? We're going to figure that out. Right. So the main problem we're going to answer today is shown on the screen here. We are going to evaluate this integration. Now, my intention is to evaluate this to produce an exact solution. All right. Okay, let's get started. Now, to do this, we can carry out two strategies here. The first one is simplification strategy. So I'm going to rewrite this. Yeah. Okay, so maybe I'm going to rewrite it directly from here. It's easier. Okay, I would say that this integration we can simplify in such a way because there's a common factor here. Okay, so there you have it. And then these rational functions that involved in this integration should be quite direct from the past knowledge. We found that the integration that involve rational functions would be natural log. Okay, now that is quite direct here. It's just a recap on how to integrate rational function. So the integration of rational function is a natural log in this way. Now we're going to evaluate this by substitute both the x equal to 0 lower boundary and the upper boundary here. We're going to get, in this case, a ln 3 here minus a ln 2 here. And then of course we can simplify that to half ln by applying logarithmic algorithm here or logarithmic property, we will be able to get ln 2 over 3 over 2. Right? Okay, so there you have it. Or you can write that as 1 over 2 ln 1.5. Okay, so that will be our exact evaluation of these integrations here. I hope that is clear. All right. Now the second strategy. Okay. The second strategy, I'm going to write it down here in a different color so that it's easier to see here. Instead of simplifying that, we can actually leave it as it is. Okay, so that is 1 over 2x plus 4. I'll just rewrite that one more time. And then by using one of the integrations identity for rational functions, we can actually write this as a ln. So by using one of the identity, we can write that as ln 2x plus 4. And then we have to divide by the coefficients of the x here. So the coefficient is 2. Okay, so that will be 1 0 here. Okay, so there will be 1 0. And then in this case, we can simplify that by substitute the upper boundary and the lower boundary here. So I'm going to try this out. So there's a constant 2 here. I can actually take this out here. All right, now you would notice that this section here and this section here is totally different. So how interesting is that? We're going to finish off and then check whether the final exact answer is the same. It'll be very interesting to find out. Right? So here we're going to put in we're going to substitute 1 into x. So that will be a 6 minus a ln 4 here. and then that is a half ln 6 over 4, and then that is indirectly a ln 3 over 2, or in this case is 1.5 there. To our surprise, they are exactly the same, right? So in general, we can apply the simplification method, or we can apply the formula directly. So both of them would yield the same result. Now, in this case, I can conclude that this integration can be given as, if I'm not evaluating that, I'm just trying to write the integrated form. So that would be, by using the first strategy, I would end up with ln x2 over 2. If I put the half over inside the bracket, now that would be 1, 0. Whereas if I apply this identity strategy, I would end up with, also by putting a half inside there, I would end up with 2x plus 4 divided by 2. So the conclusion is both of these yield the same result. So doesn't matter which method you fancy, yeah, both of them will yield the same result. So I hope this has been useful exposure to all of you. Right? Thank you very much for watching. Don't forget, if you like what you're looking at, do subscribe and then click the notification bell to get the latest videos on mathematics. Right? Thank you very much.